Hi, this is Team Petrifac's Project Hack, and our hack is centered around a hazard recognition tool. The teams consist of Holly Robertson, Zamira Nasarova, Sarah Bigri, Ryan Tom, and Andy Innes, all our Petrifac employees. We were joined by Mohammed Hamida, who's a computer science and maths student from St Andrews University, who was an external attendee to the Project Hack. Our problem statement circled around hazard reporting. We were actioned with trying to relax some of the administrative burdens around the hazard reporting process. It's a process which is largely reliant on manual identification of hazards and report generation, and we want to streamline the reporting process on site to improve uptake and accuracy. So we proposed that a more streamlined approach would be used by using object recognition to partially automate and standardise hazard report writing process and remove some of the administrative burdens which can potentially minimise reporting of hazards. The proposal was to create an app that can be used on construction sites to capture images, automatically record hazard data, using object recognition to populate the hazard register in standardised format. We have a series of categories which we would, within the business, we would categorise hazards under, as you can see by the bullet pointed list. For the purpose of the Project Hack, we focused on non-compliance, but this can be expanded to other categories through further development of the model. Our architecture diagram shows that we are using Power Apps to generate the app, which has a two-way interface with SharePoint. We used Power Automate to link the Power Apps to Python, which then uploaded some information to SharePoint and provided a final output via Power BI. We had a tie into Python using machine learning image recognition to take the images which were uploaded from the app and to identify the images into specific categories. Now, the app was designed for standard issue tablets on construction sites. The user takes an image of the hazard in the app using the built-in camera. The image is uploaded into a folder within SharePoint site via Power Automate. Once the image was in SharePoint, the machine learning image recognition is run in Python to scan the image to identify the hazard category, in addition to providing secondary hazard properties such as the GPS location of the hazard, the date, the time, etc. All the relevant information on this was all uploaded to a SharePoint list to build up a hazard register and automate what's previously a manual process. The Power App screenshots. This is just the interface of the app. As you can see, a few screens on here. First one is allowing the user to take a picture of a hazard and upload the hazard with some key categorizations on there. The user is able to modify the information within the app, and the final information is shown on the SharePoint list, as you can see by the top right screen. Here's an overall view of the app in a demo. As you can see, open up the app, the landing page here. Initially, the user can go and capture a hazard within the app, which links to the camera. Here's the image of just a car. For the purposes of the trial. As you can see, once the picture is captured, a thumbnail is uploaded, and the user can then go and categorize the hazard with whatever the applicable field is. By pressing the upload button, the image and the information is uploaded, as you can see with the prompt box that appears. Information associated with that is all appearing on the screen to the right. As you can see, there's a list of all the images that have been taken, along with supplementary information around the time, the date, the categorizations. The user within the app can go and edit records for individual files to provide supplementary information or change something if there's been a wrong selection made. As you can see, and that updates the hazard record. Just to show that in action, we'll go back to the records, and as you can see, that image properties have been changed. Power Automate is then used to take that image and upload it to a SharePoint site from the Power app. It's a fairly simple interface, and it's detailed in 3 screenshots. Now we now have Python kicking in and doing the machine learning and looking at the image that we've uploaded. So we have gone for example images for the training model. So we picked a simple image of a car and whether it was on fire or not on fire. We initially started looking at chairs to see whether a chair standing upright or a chair on its side was something we could map in, but we find difficulty with getting the image recognition to work properly because it wasn't specific enough. So we've gone for the car on fire, not on fire. Amira will explain this in the next slide. A little bit of detail about our Python interfaces here. Machine learning module was using TensorFlow, trained on circa 700 images using a 90-10 split for training and test. We did some web scraping using Beautiful Soup and Selenium of images for the machine learning module. We fell back on a Google Chrome extension due to time constraints over the weekend. And there was some pandas used for some data engineering. Final output from Python was an output to Excel detailing the image properties to allow for further data analysis and output to Power BI for additional reporting. That's just a couple of screens showing Python and what our 2 kind of main scripts we're doing. And here's a summary from Samira on what that was entailed.
So this is our script. When we started this work, we had to create 2 folders, test and train, and we split. This was our data set for the Python script, and in each of them we had 2 categories, a car and a burning car, and with 700 images in the train folder in each of these, about 700 images, and in the test folder again for each of these we had about 80 images. The test folder was used to test the performance of the artificial intelligence model as it is training, and the dataset has been arranged for the training of the model to recognize a car and a burning car. And this was the model, and we ran it 8 times. It was very slow. It took about 3 hours. And it showed here on the console, you can see that with each epoch, it showed that accuracy increased. Here 8 out of 8, and accuracy is about 84%. Then we run the image recognition tool using this script. For that we used images in this folder, and these were the results that we received. The image recognition tool predicted all the images to be the images of cars. It did not recognize burning car images. We think it could be because we did not have enough images to train and test the model. They recommended about at least 900 images for the trained dataset, and at least 200 for the test dataset. And another reason could be that we run the model trainer only 8 times instead of the recommended 200 times.
And as you can see, our dashboard output is just providing some detail on that accuracy and some other supplementary information around the final SharePoint list. So during the project help, we found we had a few constraints and a few things to troubleshoot. Initially, we had a high complexity project, which was at expert level, and with a limited experienced team who were all run through the apprentice program. We ran into issues with app testing because we were working in the project success environment. We weren't able to initially test the app because we couldn't download the app to our accounts, which delayed the testing. We managed to get over that hurdle, and once we did, things managed to move quite quickly thereafter. As we touched on, we had issues around the image recognition and machine learning element, mainly due to time and inability to get the volume that we really needed to get that machine learning working in effect. So as I said, initially we had a specific image search criteria was a problem. Started off looking at chairs, and the parameters we found were too wide and varied to glean accurate learning data. So we had to change our tack a little bit, which was a change early doors. On the machine learning and the image recognition, we manually saved images from the internet, but we had too few images to train the model, changing the machine learning element, which led to inaccurate results on initial script runs. There was a web scraping exercise carried out to build a larger repository of images to improve the module accuracy via Beautiful Soup. This script worked on specific websites, but identifying the relevant image URLs in Google and Bing searches proved to be difficult, and we didn't have the time to manually save the volume of images to positively impact the machine learning accuracy. Due to the system and time constraints, the team were unable to run the model with the desired frequency that would have improved the output accuracy. But as you see from Zumaira's summary, we did get the accuracy improving as we ran through those 8 runs. So our object recognition model, as I said, was at 84% accuracy after the 8 runs. We intended we would be able to expand this the actual subject matter of the identification to detect more hazards by building up a larger repository of images of both hazards and non-hazard states from internal sources and external sources to train the model to recognize other items. So internal would be further submissions from users of the app or images submitted from construction survey sites during surveys, etc. Or by simply a gleaning of external data from the web or image libraries. Currently, our solutions consist of a object recognition and a power app. Now, to integrate the 2 components into a single solution, the intention would be that we would build the existing build a Python interface into the existing Power Automate interface. So the introduction of a trigger point within the current Power Automate process to initiate the run of the Python script for the image recognition, which would close the loop and introduce this as a single solution.